press pause and answer the question.
Which of the following would be an equation that shares no solutions with the following equation? And it gives you an equation. Now, you have to remember that all we're talking about when we're talking about these types of equations where you have a y and an x and nothing squared and no other variables, we're talking about some relationship where as x changes, y changes, and as y changes, x changes, and there's this kind of series of numbers that seems to work for both. Some number for x and some number for y that makes the whole thing work. And if we plot those series of numbers out on a coordinate plane, we get a line. So basically, if we have two lines, and that's what we're talking about here, the one that's given, and then we have to choose another one that shares no solutions with the one that's given. If we have two lines, in most situations, if they're not parallel and they're not the same line, then they're going to cross somewhere. So we have two lines. If they're not parallel, eventually they will cross. And where those two lines cross, that's the solution that's common to both equations. So we have an x and a y that works for this line, and we have an x and a y that works for that line. It's the same x and a y. We have one solution. Occasionally, we have no solutions. When we have no solutions, that means that the two lines are parallel. So we have a line here, and we have another line described by another equation here, and the two never meet. So there's never an x and a y value that works for both sets of equations. And then also occasionally, we have a situation where we have the same line. We have two lines, but really they're the same equation. It's just one of them has been manipulated around to make it look like maybe it's not the same equation, but it is. And in that case, for every value of x and y that works with this equation, the first equation, it also, that same combination of x and y work for the second equation. So in this particular question, this item on this test, we're looking for no solutions. So if no solutions, that means we're looking for a parallel line, but a different line, not the exact same one. So you see the possible choices are in the form y equals mx plus b. It's also a form that we're probably very familiar with. So let's go ahead and take our equation that they've given us, this negative 4y minus 3x equals 20. And let's go ahead and rearrange it so it's in our familiar y equals mx plus b. So we're going to add 3x to both sides. We get negative 4y equals 3x plus 20. We'll divide both sides by negative 4. And then we get y equals negative 3/4 x minus, because we've divided by 4, minus 20 over 4. And 20 over 4 is just 5, so that reduces to y equals negative 3/4 x minus 5. All right, so what we're looking for is we're looking for something that's parallel but is not the same equation. So if we look over here, we're looking for something that's parallel. It's got to have the same slope. So we're looking for a slope of negative 3/4. That narrows it down to these two. Y equals negative 3/4 x minus 5, and y equals negative 3/4 x plus 20. Now, one of these, this y equals negative 3/4 x minus 5, well, that's no good, because that's the exact same line. That's our third condition where it's the same equation. So this right here and this right here are actually the same equation, just manipulated in different ways, but it's the same relationship of x and y. Our correct answer is this one, negative 3/4 x plus 20, because it has a different y-intercept, but the same slope. Now, if you take the negative 3/4, just as an aside, if you take negative 3/4 and you flip it around, then it becomes negative 4/3, and you take the negative value of that. So we're taking the negative reciprocal. So negative 3/4 becomes 4/3. That's like, we'll see it in something like here. If you happen to ever see a slope that's a negative reciprocal of another slope, that means that the two lines are perpendicular to one another. Just as an aside, if you see that on a question.